Dear students, how are you all? Hope that you are doing good. In our lesson today, we're going to start studying chapter 22, which is talking about organic chemistry. And we will start with our first section, which is organic compounds and what we mean by organic compound. As you can see here on this page, the organic compounds can be defined as covalently bonded compounds containing carbon, excluding carbonate and oxides. So carbonate, which is CO3 2 minus, it is an organic compound, and oxides like, for example, carbon dioxide and carbon monoxide, CO and CO2, also are not organic compounds. So the organic compounds are mainly made of carbon and usually with hydrogen with some other elements. Now, why we are talking about organic compounds? Actually, the organic compounds and organic chemistry in general is a very important section of chemistry because a lot of industries and products around us are actually related to the organic chemistry. So we have to understand the main basics of carbon to be able to produce such products. Now, the uniqueness of carbon bonding results in many organic compounds actually, because carbon, as we know, contains 4 valence electrons. And the 4 valence electrons are located in sp3 hybrid orbitals. And the ability of carbon to share the electrons with other elements and the, let's say, medium electronegativity of carbon also give a very unique properties for carbon. For example, as you can see here in this picture, we can make a lot of compounds that are made of chains like aspirin, polyethylene, plastic bags, citric acid in fruits, amino acids in animals and all living organisms, and a lot of other things around us, our bodies, our life. Many products that you use are actually related to the organic compound. For example, let's just talk about only one product, which is plastic. All types of plastic are chains of carbon atoms. The plastics of your mobiles, your glasses, your laptops, your pads, your tabs, everything is made of carbon. Chairs, tables, a lot of technological devices are actually made of carbon. This is why organic chemistry is very important. Now, as you can see here, carbon-carbon bond. Because carbon is able to make a very long chains of carbon atoms connected to each other, this is what we called as catenation, which is a covalent bonding of an element to itself to form a chain or a ring. So as you can see here in this shape, fructose carbon atoms could form a ring or could form a very long chain in fatty acids. So this is the meaning of catenation. Now, when carbon bonding to other elements, it will form a compounds named hydrocarbons. So the hydrocarbons are composed of only carbon and hydrogen. They are the simplest organic compounds. So the simplest organic compounds are made of only carbon with hydrogen, no other elements. But of course, as you know, we have another elements that could be connected in such compounds like oxygen, nitrogen, and sulfur. So they known with another compounds. They have a special functional group that we're going to talk about it later in this chapter. Now, the arrangement of atoms also. Now we are talking, guys, about the 3D. We are talking about the shape of the compound in 3 dimension. We are not talking about 2 dimensions, but we are talking about the 3 dimensions. Now the arrangement of atoms here could make many different compounds for the same number of atoms inside the compound. And this is what we call by isomers. So compounds that have the same molecular formula but different structural formula are called isomers. Now, what we mean by structural formula? The structural formula is a formula that indicates the number and type of atoms present in a molecule and also shows the bonding arrangement of the atom. So, if for example we have C2H6, this is the molecular formula for ethane. This is molecular formula. We can know the number of atoms here in the compound with the type of atoms. So as you can see here, we have 2 carbon atoms with 6 hydrogen atoms. But how they are bonded to each other? How they are connected to each other? We don't know. We can't know from the molecular formula. So we have to draw a structural formula, which is C, H, and H, with H, and another one. Now here we can see that we have 2 carbon atoms and 6 hydrogen atoms, and we can see how they are connected to each other. So this is what we call structural formula. So the structural formula can show us how the atoms are bonded to each other. Of course, we have more complex compounds, like for example C4H10. How we can draw this compound? We can do it 1, 2, 3, 4 carbon atoms, then distribute the 10 hydrogen atoms around the carbon, and you know that here we have the hydrogen atoms around. So this is the structural formula for this compound, which is called butane. Now, what we mean by isomers? If we look at this compound, as you can see here, we can draw it with another form. For example, we can write 1, 2, 3, and the 4th carbon atoms could be here. Then we draw the hydrogen atoms. If we look at both compounds here, guys, and count, as you can see here, the number of atoms, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms with 4 carbon atoms. If we go to the other compound here, this one, and count the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have another H here, so this is 10. So both compounds have the same number of carbon atoms with the same number of hydrogen atoms, but actually they are totally different compounds. This is what we called isomers. So isomers means that we have a compounds that have the same molecular formula but with a different structural formula. So they are totally different compounds because the arrangement of atoms and the way how the atoms are connected to each other also determine the identity of the compound. And as the number of atoms increases, that means that we can have more than 1 or 2 or 3 isomers. So the number of isomers also increases. This is the same compound as we draw it. And we can draw the structural formula in this way by drawing the lines as a bonds between atoms, or we can just draw and write the number of hydrogen, and we already know that these 3 hydrogen atoms are bonded, as we can see here on this side, the other one on the left, and the CH here CH is also same thing like this one here, the H is bonded to C, and CH3 here, same thing. Those 3 H atoms are only bonded to this carbon. They are not related to other or to any other carbon atoms. They are related only to the carbon atoms here that they are bonded to it. Now the isomer itself could be, or we could have 2 types of isomers. First one called structural isomers or constitutional isomers, which are isomers that the atoms are bound together in a different order, as you can see. Let's take another example. What if we have carbon compound with 5 hydrogen bonds, hydrogen atoms, C5H12. First one, of course, 1, 2, 3, 4, 5. And no need to write hydrogen around here. Already you have to know that the other side of the line or the bond is already hydrogen. And usually we can just draw it like this way. 1, 2, 3, 4, 5. If we have any other atom here, you have to write it. So if you have, for example, Cl, we have to write Cl. But if we didn't write Cl here, that means that the other atoms in the other side are hydrogen. So this is the first isomer for C5H12. Or we can draw 1, 2, 3, 4. We can put the carbon atoms here to have this compound. So this is a second isomer. Or what if we put 1, 2, 3, 4. Instead of use this arrow to contain the carbon, what if we put it here on this side? Actually, these two compounds are totally the same, because the naming system, we're going to talk about it later also in this chapter, will give us the same name for these two compounds. Or if you flip this compound to the other side, just flip it, you will have the same compound. So this is not an isomer, because this one is equal to this one. They are the same. So can we have a third one? Of course we can. 1, 2, 3, 4, 5. This is a third isomer for C5H12. Okay, what about this one? Is it an isomer? Actually, no. Because this atom here, it is connected to the fourth atom, this one. So you can just flip it this way. Or imagine that if you take this compound from the last atoms here and here, and you stretch it, you will have same thing, 1, 2, 3, 4, 5, the same shape of the first one, as you can see here. So you can imagine it like this one. If you have a chain, or this way, if you stretch it, it will be straight. This is the same thing. If you stretch this one from here, it will be the same. Or if you flip it, for example, this one and this one, if you flip this one to this side, you will have the same of the other compound here. So we cannot consider these two compounds or shapes as isomers, because actually they are the same. Okay, so the isomers should have a different arrangement and a different way how the atoms are bonded to each other. The other type of isomers, as we said, the first one is called structural isomers or constitutional isomers. Now the second type of it, as you can see here, these two isomers, they have a totally different physical and chemical properties because they are totally different compounds. The first one called, as we said, butane here, and this one is 2-methylpropane. So it is totally different with a different melting and boiling point and also different density. Now the second type of isomers is called geometric isomers. Now in this type, guys, the order of atoms bonding is the same, which means that the order how the atoms are bonded together follow the same order, the same arrangement, but the difference between them is actually in the space. So if we are talking about 3 dimensions, you will see that the arrangement of the atoms is different in 3D. As you can see here, the geometric isomers could be cis or trans. Now here we have 2 carbon atoms with 2 chlorine atoms with 2 hydrogen atoms. If you look at the chlorine here, both the chlorine atoms are located at the same level in 3D. So this is what we called cis isomers. This is 1,2-dichloromethane. And this is also 1,2-dichloromethane. But here, the arrangement of the chlorine atoms in the space, the 2 chlorine atoms are located in a different levels. So this is trans. So this one is called cis 1,2-dichloroethene. And this one is called trans 1,2-dichloroethene. For example, as you can see here, what if we have C, OH, H, OH. In this shape here, the hydroxyl group are both located in the same level. So this is cis isomer. While if we have COH and the OH is here, this is the trans isomer. Because the arrangement in 3 dimensions is different. They are not located in the same level. This section is just an introduction for the main concepts here. We have another example here, as you can see. Two groups, even if they are not the same groups, but look here, 2 carbon atoms or 2 carbon groups are located in the same level here. So here we have cis 11, while here they are located in a different, the carbonyl groups are located in a different level in the 3D. So here we have trans isomer for the same compound. This is all for our session today, and I hope you guys just solve the formative assessment here to practice and to be able to differentiate between types of isomers and when we can consider that compounds are isomers or the same thing. Thank you and be safe.